This is a P3 replay for the Aromatic Heterocycles lesson, and in this problem the question text recommends that you go to Schmo and consider the pi molecular orbitals of this compound A, but actually if you read the question text you don't even need to go to Schmo in order to get this problem correct, as long as you understand how heteroatoms contribute to pi systems. It's a good idea to use Schmo as a check if you feel you need it, but in situations where you think you have the approach that will solve the problem in the quickest amount of time, it's often better to follow that through, submit, and then diagnose your errors from there. So for this particular problem, all we need to do is fill in double bonds and lone pairs, things like that, to achieve 12 pi electrons in this molecule. So I'm going to go ahead and lay down basically a carbon skeleton of the molecule, and then we'll adjust this skeleton, double bonds around it, heteroatoms, etc., to reflect the compound A. So I'm going to change these two to nitrogens, and we need every single atom to be sp2 hybridized, and so I can achieve this by adding double bonds around the outside of the structure. So here's two more nitrogens. As a starting point, I might do something like this. But now I've run into trouble because this carbon is not sp2 hybridized, and so I might try shifting double bonds around like so. And now we're at a point where every atom is sp2 hybridized. Now the question then becomes, does the compound have 12 pi electrons? Well, let's count up the number of pi electrons. 2 here, 4, 6, and 8 from double bonds. These two nitrogens are in threes, so they contribute 2 electrons each to the pi system. That leads us to 10 and 12. So in fact, this is actually the correct response, and it is, I believe, the only way that you can make every atom sp2 hybridized in this compound without introducing charges or anything less reliable like that. So it's a good idea to follow your gut instinct for exam problems that seem simple, and this is an example of a problem that seems very simple. All you have to do is add double bonds to the structure. If you're barking up the wrong tree, then submit, make sure you are, and reevaluate your approach. If you build this molecule in Schmo, what you'll find is that Schmo tells you it has 12 pi electrons. The reason is that Schmo is able to sense the location of these double bonds, but it's really up to you to determine their locations and to determine whether these nitrogens should be in 2 or in 3.